Hi, this is Mrs. Lemke, and this video lesson is about how knowing the order of operations can actually help you with solving. And that is because basically when you're trying to solve an equation, we're trying to undo various parts of an expression to isolate the variable. And so we reverse the order of operations that we use in arithmetic. If you have an expression that has only numbers, you're doing arithmetic. And in arithmetic, we follow that, please excuse my dear Aunt Sally, order, parentheses, exponents, multiply and divide, add and subtract. But if we want to undo those things to get x alone and isolated, we actually go in the reverse. An analogy that we thought about in preparing today's topic was to think about helping like a little kid get dressed. So if we were to get a little kid ready for the day, like in this picture, she might put on her t-shirt, then her green jacket, then her raincoat on top. But later on, when she comes back indoors, you're going to have to undo that process. So order of operations is for evaluation when you just have numbers, and then you undo that process when you're solving. Okay, that's a easy way to think of it, maybe. Okay, so these notes have 4 sets of problems. On the left side, you will see a problem that has just numbers. So it's arithmetic, right? This side is arithmetic. Whereas the other side, the right-hand example, is an algebra problem. And we know it's an algebra problem. Oops. We know it's an algebra problem. I get too close to the margin and it gets mad at me. Thinks it knows what I want it to do. Okay. We know this is an algebra problem. First of all, there's a variable in it. Secondly, it's asking us to solve, right, to find out what x is to isolate that variable. Over here on the arithmetic side, there isn't a variable to isolate. There also isn't even an equation. It's just an expression. Just do the math. Okay, so let's start out with the arithmetic side. I'm going to follow order of operations. I don't see any parentheses. I do see some multiplication, so I will do the multiplication. Okay, and then I'm going to go on and subtract. Okay, so in this simplification problem, we first used multiplication, and then we subtracted. That's supposed to be a U, subtracted. Okay, on the other side, this example, I want to get x by itself. Okay, now you might not even have really internalized like why you do the steps that you do in an algebra problem. Like a lot of you, I hope everyone actually, knows that the first step here would be to add 7 to both sides. So then we would get 8 equals 3x, and then we would divide both sides by 3, and that's what allows us to have x by itself. X is 8 over 3. Now, something that's interesting there is to just observe the order in which we did things. So in this problem, since it was a solving problem, we had to undo the order of operations. So the first thing that we did was that adding 7. So we used addition, and then we used division. Now, if you compare the 2 original problems, the format isn't, strongly different. We had 3 times something minus 7. Over here, we had 3 times something minus 7. But notice what we filled in. On the left, we multiplied, then subtracted. On the right, we added and then divided. We were undoing. We're going in the backwards order of operations. All right, let's take a look over at our next pair. Okay, so again, these are somewhat similar in that you have a number, something squared subtraction, a number, something squared subtraction. Okay, so I was trying to make questions that look kind of the same, but they are very structurally different. On the left side over here, we're doing our arithmetic problem. I think, okay, so parentheses don't have any. Exponents do have some. So I have 3 to the second, which is 9. And then I'm going to multiply. And then I'm going to subtract. And of course, you can be using your calculator through this to help you with various steps, but you really should have an understanding of the order in which things happen. That way you can avoid having a mistake in terms of how you put things into the calculator, okay? So that was arithmetic, and in this simplifying problem, we used exponents, then we use multiplication, and then we use subtraction. Okay, so I just shorthanded that. Exponents, then multiplication, then subtraction. On the algebra side, okay, we're trying to get x by itself. We would add 14 to both sides. Okay, so the first thing I did was add. The next thing that we would do would be to divide both sides by 3. And then I need to actually do that division. 36 divided by 3 is 12. So then I used division. And then I need to get rid of that square, that exponent. And you do that by taking the square root. Hopefully you remember from earlier this year that the square root of a variable squared causes the other side of the equation to pick up a plus and minus. And 12, you want to break down that radical to square root of 4 times square root of 3. I'm not using 6 and 2, because even though 6 times 2 is 12, neither of those is a perfect square. Here we would get positive 2 root 3 as well as negative 2 root 3 as our two solutions, okay? So the last thing we used was a square root. Now, if you compare side to side here, exponents and square roots are opposites. Multiplication and division are opposites. And subtraction and addition are opposites. So you're using opposite operations and also the opposite order. It's a major undo, right? All of this solving is undoing our order of operations. Right, let's take a look at the next pair. So this is designed to be similar in that this has subtraction inside of a square root, so does this. Okay, on the arithmetic side, remember that inside of a square root has an implied parenthesis, right? You have to do everything inside that radical operator, that square root operator. So 18 minus 2 is 16, and the square root of 16 is 4. Okay, it is not plus or minus 4. You're getting confused if you think that. X squared equal to 16 would lead to square rooting both sides, which would lead to x being equal to positive or negative root 16, which is 4. So having this situation that started out as an algebra problem is what leads to two solutions, right? Something squared is 16. 4 times 4 is 16. Also, negative 4 times negative 4 is 16. But a square root of 16 is just the number 4, okay? It's on a number line to the right of 0. This is where square root of 16 is on a number line. Opposite of square root of 16 is over here. Those are two different numbers, okay? All right, that was a little bit of a digression, but just thought I'd bring it up while we're in the neighborhood. All right, on the right side, we need to solve, okay? So what we're going to do is get rid of the square root by first, well, what we did back in the day was to rewrite this as to the 1/2. Okay, so to get rid of that square root, whether it's in radical form or in exponent form, we're going to use the reciprocal power. The opposite of a square root is squaring. Okay, so we're squaring both sides. We get 225 equals, this part makes a power or an exponent of 1. So that side's just x minus 3. And then we'd add over, add 3 to both sides. Okay, so if you go back and rethink what we did in each problem, in the left side, on the arithmetic side, we did the subtraction, and then we took a square root. Whereas in the solving one, we used squares, we squared both sides, and then we added. Okay, so you can see these are opposite operations, these are opposite operations, and the order is actually reversed too. Okay, just like with the jacket, right? Put on a t-shirt, then the green jacket, then the raincoat, and then take off the raincoat, take off the jacket, take off the t-shirt, right? That's the order in reverse. Okay, the last pair is a pair that has logs, okay? And we remember that a log is an exponent. That is a key thing for us to remember. Okay, so on the arithmetic side, I know this is arithmetic, nothing there is a variable. It's all numbers in the log function, okay? So I'm going to use my order of operations. I'm going to do the inside of those parentheses first. So I've got the base 2 log of 128. And I want to remember that a log is asking for an exponent. So my thought cloud here is 2 to something equals 128. That is probably very unclear to see, but 2, I'll write bigger. 2 to something equals 128 is what I'm trying to write. Okay? All right. Write neater than me, okay? All right, so 2 to the something equals 128 is what we're trying to think about. And so I could just try some stuff, right? 2 times 2 is 4. Then this would be 8, 16, 32, 64, 128. So 1, 2, 3, 4, 5, 6, 7. So 2 to the 7th is 128. So that means that the base 2 log of 128 is 7. This is my thought cloud work, okay, my thinking in my head, okay, or with a pencil, thinking with a pencil. Okay, so what we did in this is we had to add first, and then we evaluated the log, okay, thought about an exponent. Okay, on the other side, what I'm going to do is switch this to exponential form. So the base of the log is the big number. A log is an exponent, so the 5 is an exponent, and that equals x plus 3. So the first thing we did was to switch it to exponential form and get rid of the log. And the next thing we're going to do is a little calculation here. That's 32. I remember that 2 times 2 is 4, 8, 16, 32. See? 32. And then I will subtract the 3 over. Okay, so on the simplifying side, we did addition inside our parentheses, and then we dealt with the log and thought about exponents. And we do the reverse of that when we have to solve a similar equation. So I hope that this is a nice smattering for you of just some various different kinds of solving equations. That's what this whole unit is about. And at this point, you need to make sure that your teacher sees your video notes before you leave class. Then work on the problem set and make sure you upload your problem set work to your portfolio. Thanks.